Hi, everybody. Welcome to this speak. I'm Samuel David Roncal Vidal. I am academic software coordinator at Universidad Peruana UnÄon in Lima, Peru. So welcome to this speak that is called How an Event-Driven Architecture Changed the Way I Design Software. So let's talk about something about me. Let me introduce myself. I'm from Peru. I'm Peruvian. I'm Seventh-day Adventist. And I have a really good inspiration for me for be a better professional. That is my family. I have my wife, my mom, my father, and my two sisters, and also my wife's family. So I'm really happy for that. You know? They are my motivation for every day. I'm a systems engineer, you know? And also I'm a student member for the IEEE. No? And also I have been certified in design thinking and Scrum. I have been working for 8 years. No? So I started working at the banking sector as a data analyst. And then I moved to educational sector. So I started working on the Universidad Peruana UnÄon as a system analyst. And then I have moved to a new labor as academic software coordinator. My favorite program languages are PHP, Java, and Python. Oh, I love Python. I think I'm a little bit better in that language programming. And also I have some favorite platforms as a mobile platform. I like Ionic. And also I like the backend programmation. That's my favorite part and platform. So I have some research topics that are my favorite: software architecture, obviously event-driven architecture. I really love text-to-speech. I think that it's an amazing technology. And also I have been reading about sentiment analysis. You can find me on my social networks like Twitter, LinkedIn, Medium, or GitHub. But let's talk about something more important. The question that I had made to me is how an event-driven architecture changed the way I design software. That's the question. And first of all, we have to understand what is an event-driven architecture. So we have a definition. An event-driven architecture is a pattern that uses events to trigger and communicate between decoupled services, and is common in modern applications that were built with microservices. So we have key components for them, and they are producers, routers, and consumers. So what are they? No? What are event producers? What are event routers? And what are event consumers? So we can understand all of them as event producers that are all the software components that generate events through action. For example, a user makes a click in some button on a front-end application. So that's an event producer. Maybe it was by a mobile application when someone login, when someone make a payment, make an online payment, and etc. And we can understand about event routers that the components that filters and pushes events to consumers. Sometimes we have a mesh for all the software that will route or enroute the events. No? So we understand them as event routers. No? And finally, we have event consumers that are components of the software that listen for events and execute tasks. For example, we can program some consumers in any language that we like. For example, PHP, Python, Java, C, and C#, and the list is really big. No? There are many options for them. So let's talk about use cases. We can find event-driven architecture working in email dispatching. No? Maybe a user has filled some formula, some form on the website, and then an email is dispatched. So we can find event-driven architecture in that case. Also payment processing, fraud detection, because maybe a transaction wasn't done by the titular of the credit card. So we can find a series of tasks that were executed after that payment. So we can use that on fraud detection. Also for background tasks, I really like to use either event-driven architecture in that kind of use cases, because sometimes you need to execute a lot of actions that were triggered by an event, by an action, and you can wait for the response. I mean, 2 minutes, 1 minute, the user can wait for that. So we move all the logic, the key logic, to a background task, and then we have an happy user, and really happy user. So I really like that use case. We can find also on performance monitoring. I really like site reliability engineering. I have read about that, and I think that event-driven architecture fits perfectly for calculate some indicators as budget error, to calculate indicators like delay, and some more things like that. Real-time marketing, data replication for move and copy the data from scheme A to scheme B. So we cannot do that manually. We can not do that by a cron job. Well, we have event-driven architecture, and we can program some consumer, configure some router, and program some consumer, and then we can execute that kind of work. And also, we can use it for on-demand data loading, and we can find lots of more use cases. No? So what are the characteristics of this really useful architecture? Well, event-driven architecture is so much customizable because it fits to your infrastructure that you have in your organization. So if you are in cloud, you can find a really good solution for them. You have in-house solution, maybe because it's a really small organization or something like that, in countries that cloud computing is not too advanced. Well, that's not a problem. You can use that. Also, it brings interoperability to the software components. And why do I say that? I say that because you can connect some key components from your software solution, and it doesn't matter what programming language they use. That's other characteristic, is language agnostic. So we can do language agnostic programming because as we have seen in some slides before, you can program some consumer in PHP, you can use Python, you can use Java, and you can mix all of them, and you can connect all of them, and you can avoid some redundant API calls using this really awesome architecture. Another characteristic is scalability. Event-driven architecture helps you scaling because all we know that technology is growing in steps, really bigger steps, so you can adapt to that. So if you have the need to build more hardware on the cloud, you can do that, implement the brokers, and enroute all the events and the message to the solution. So let's continue. We are going to see the benefits of language agnostic solutions. We have talked about this a few moments ago. It reduces the learning curve, because your team can program in the favorite language, and not also the favorite language, also in their strange language. I mean, my team is the best in PHP. I think it's only an example. So your team can work with that. My team has its strengths with strengths with Python. So you can program in Python, you can use the package that already exists like Celery, and it reduces the learning curve. So you can dedicate that time to another task. Also, it allows the team to elaborate a solution according to their experience, according to their strengths. And also it's easy to migrate in case of a considerable technological improvement, because we have seen the scalability a little moment ago. So it reduces the dependency on specific technologies, because you are not married with one programming language. You can move in every time for a better solution, and that it's a really good benefit of that. So let's talk about the use case. The use case is a teacher evaluation module for Universidad Peruana UnÄon. And the use case took place at the Universidad Peruana UnÄon. It's my labor center. And it has 3 campuses in Lima, Juliaca, and Tarapoto. And the university offers programs to undergraduate and graduate people. No? And it forms of a network of Adventist World Educational Network that it has 118 universities. So they had the necessity to evaluate their teachers in each campus, no? And prepare and consolidate some data based on academic indicators that they defined previously. No? So that was a really challenge for my team, because we had a lot of data to calculate. We have to consolidate that data. We have to present that data in a report. So the end user needs to have that information in real time, on demand. And that was a really big challenge for us. Likewise, the service system that were being used has its front end developed in Angular, and the backend uses PHP. So the uses of questionnaires for the different academic processes are quite concurrent. And there were more academic processes that were using the module. So we have concurrence, and it requires a high uninterrupted performance. So that was a really big challenge. So the previous situation was that an Angular client was consuming REST APIs from a Laravel project. This Laravel project was the backend. And these APIs were running under a proxy, a server that were proxied using Nginx. So all we know that every time an application is proxied, we have to adapt to some condition, some certain condition, like timeout limits, like course restriction, and for example, file upload, limit size, and things like that. So a task with a long response time will make a timeout error response. So that will make the software development prone to fail. So that was a problem, because they needed on-demand data, and it was required, and we have started to searching for a solution. This module performed a synchronization task between several schemas and database engines. So we have mixed some tables that were located in different schemes and also different database engines. That was the most really difficult part, because some tables were on an Oracle database, another was on a MySQL database, and we have to mix that and make a consolidate and all of that things only with a click. So there was a feature that made this architecture pattern fit perfectly, and that's event-driven architecture, because it allows us to give the total control to the user in terms of data management. So what I didn't want to do is to do manual actions. No manual actions. That wasn't allowed. Do not increase the monolith, because we had an application that makes redundant calls, redundant API calls, and we didn't want to increase that, to make the problem bigger. So we have to find a solution. And it's true that it's possible to work with some referential data using temporary tables, using periodic data loads, using solutions like that are not bad, but they are not the perfect solution that allows to the end user to have total control of the data, because we didn't want to make them to wait for the data, because the information process was really important. So they have to get the responses on real time. In the we started to work on a solution. So applying all the concepts about event-driven architecture, the most important part is to identify the event. What is my event? My event will sync and consolidate that action. That's the more important part, because if you can identify the event, the rest of the task or the challenge is more easy, because you have some key components working. So you can identify these applications that makes actions are going to be my producers. I'm going to instantiate some software for en route all the event messages, so that are going to be my router. Also an event mesh, no, also it's fine. And finally, my key components of the software, my consumers, my consumers are going to be working with a process monitor like supervisor, and you can do a job internally run in the process. It doesn't matter how, but you have to find a really good way that is maintainable in time, that follows and fits on good practices also. And don't forget about continuous integration and continuous deployment. So we have 5 steps to get this goal. And the first step was analyze IT infrastructure and implement what is needed to respond to either component. So we said that was pre-pandemic. I have to say we said, but we use Zoom. So we have to use Zoom. We have some meetings. We make a requirement list talking with the stakeholders, and we started with that. We make a requirement list and deploy what the software needs, because we don't have a software to route all the events to the consumer. So we have to prepare a server and a software to do that. Okay, that forms part of my requirement list now. So we chose an event broker. RabbitMQ was chosen as our event broker. We chose a STOMP connection for sending events. So we have a client, we create a class for connect to them. We use the STOMP connection as a WebSocket, and we start to send all the events. And finally, we choose Supervisor D as a software for create workers. So then that we have the requirement list and we start to deploying some softwares. I mean, we build the infrastructure for that. We had to identify event producer, event router, and event consumer as the key ADA components that we have seen. So we have been using an Angular client, so that was our producer. Then we have the RabbitMQ as our event broker, so that was the router. That was the router. And finally, we have programmed some PHP workers that were our consumers. So we identify all our software requirements on step 3, software requirements for the programming. We have enabled ports, we have creating connections, we have programmed the logic to trigger the events from the Angular client, receiving the message by the router, and do the actions from the consumer. So we start with implementation. we have made some testing. So we start working on each requirement and test it for getting the best performance. Finally, when fulfilling all the requirements, that was the time to deploy all the solution to the final environment, to production. So we have followed that 5 steps. No, I will repeat that. Analyze IT infrastructure and implements what is needed to respond to ADA components. Identify the key components from ADA. Identify all the components, no? Producers, router and consumers. Requirements, the requirements. Do the implementation and testing. And finally, deploy all the work. So we have a solution diagram. On the left side, we have the event producer column, no? Also known as publishers. So our front-end application was our key event producer. It published all the messages through a STOMP connection that was linked with an exchange. We have created an exchange that was linked with a QA, and that QA was being listened by all of our common consumers that we have programmed. So we have done that. We can see all the solution diagram. Well, talking about the implementation, the Angular client used a library called ng2stomp.js that allows us to be able to connect to the exchange, no? That was associated with a RabbitMQ query. And finally, there were 2 consumers to process each of the requests generated by the producer. That was the Angular application. So we have setting the broker, the connect headers with the login, the passcode, the heartbeat. That is some important because the heartbeat allows you to make your connection live. No? And it was necessary to create a QE, no? With an exchange, no? And we link them in RabbitMQ for subscriptions because we were using STOMP connection that makes this possible because it uses sockets. It uses sockets. So through an Angular service, we can connect to them. No? We subscribe to them, to the exchange. And every time the user clicks on sync button, the Angular producer sends a message to the STOMP socket. So we can see that traffic using our inspect tool, our favorite inspect tool, no? For validate that. No? So we send message through an STOMP socket, then RabbitMQ routes the exchange, and that's the moment when the PHP consumer listens all the messages that are being fired, no? And then of that, it completes all the background tasks that were queued. So the WebSocket sends the event action and also makes a heartbeat for making the connection alive. That's really important. So we have the conclusion and what has changed in the way I design software with all the things that we have talked and implement and seen. Well, no more monoliths in my software solutions. No more exceptions to handle timeouts. No extra rules, no breaking rules for that. No more codes between APIs. No more redundant codes. No more, and also we have changed our mind and we got an event-driven approach. So let's be event-driven. Let's talk about events and let's talk about actions that we can do based on an event. So some people has fulfilled your form. That's an event. Some people has make some payments on a website. That's an event. Some people has make a reservation for their travel in an airplane. That's an event. Let's be event driven. We got new perspective for implementing an event mesh. So we can replace the only broker with an event mesh. So it's more sophisticated. It will be more sophisticated. Also, we it allowed us to decoupling all our logic in our next software requirements. So we started using background tasks, we started using WebStomp sockets, we started using real-time notifications, and lots of more things. So for me, that was the best solution that I could have found, because implementing an event-driven architecture not only allowed me to scale my solution, not only break the monolith, not only change my mind, it also gives the end user the power to update all the reports with the latest information. Also, this solution has a lot of potential because through a message and consumers, it could be integrated to reduce many more steps, not only in this scenario. So we can find the references that we have been using. And I have to say to all of you, thank you for participating of this speak. And I have a last tip: wisdom, first of all, acquire wisdom, and above all your possessions, acquire intelligence. So let's make this a better world. Thank you.